Hello, champs. Graphical representation of motion, that is what we are going to deal about today. Now, in graphical representation, every moving object can be plotted. Why? Because we have various plots, like, say, when we plot a graph, what do we show? In pen and paper, we are showing how much distance it is covering in what time, and many such things, right? So in front of us, we can see that there is something in table 4.3 where position of vehicle at different instance of time is given. So here let us see we are going to see the note part. All the graphs that we will discuss in the chapter are for motion in a straight line in one direction only. This is something you should keep in mind. Because you are seeing a syllabus of class 9, we are going to start with things which are simple to understand. Now, what is it? Motion in a straight line in one direction only, unidirection. In this special case, distance traveled and magnitude of displacement are equal. We know there is a difference between distance and displacement. So here distance is a scalar quantity, displacement depends on the direction and is a vector quantity. But here we are going to consider such cases where distance and displacement are going to have same magnitude. Speed and velocity will have the same magnitude. But we know the difference between distance and displacement. Distance is what? The actual path traversed or traveled by the object. And displacement is the shortest path covered by the object, by the vehicle, whatever you are talking about in a particular direction. So distance is a scalar quantity and displacement is a vector quantity. So is about speed. We know speed is equal to distance by time, right? But when we talk about distance by time, we will see that it gives the magnitude of speed. But regarding velocity, we have to see the direction. So instead of distance, we will say velocity is actually numerically equal to speed. Fine. But we have to consider displacement by time. So there will be cases where the velocity may be different, not the same as speed, not always. But we are considering such motion. Which type of motion? Motion in a straight line. That too without any change in direction. So for motion in a straight line in one direction, that is what we will consider. One more thing I said, distance and displacement will have same magnitude. So is speed and velocity having same magnitude. Now let us see table 4.3. There is data being provided. And what is the data? The position of the vehicle at time 0. That means just when the motion will be starting. It's not yet started. At time 0, the position is 0. So the body is at rest. When the time is 1 second, the position is 20 meter, 2 second, 40 meter, 3 second, 60 meter. So whenever we are seeing this thing, this data, we can see that the time is having 1 second gap. Each case we are having a gap of 1 second, right? But here in the distance, there is a gap of 20 meter. Each case we can see there is a gap of 20 meters. So 0 to 20 meter, 20 to 40 meter, 40 to 60 meter, 60 to 80 meter, everywhere there is a gap of 20 meter. Now let us see how to plot a graph. So for a graph, you may have seen many of your copies have graph papers. Okay. The practical copies also have graph paper. Classwork copies may have graph paper. So you may use one such graph paper and then you will take a sheet of the graph and these have certain divisions. Okay. Small division, big division. You take the small squares, and here we will see how to plot it. The small squares will give you a more easier plot. You will take one part of it and draw two perpendicular lines. Okay, perpendicular lines means they are at 90 degrees to each other. So the two perpendicular lines are this. This is one line and this is the other line, perpendicular line. And so what are they? They are the x and the y axis. Okay. So one is the x axis and the other is the y axis. The horizontal line is OX, which is the x axis, and the vertical one, the vertical line is OY, which is the y axis. Okay. So you refer to the table which is given, and now what we will do, we need to see with the position of 20-meter change how the plot is getting formed for 1 second difference in time. So that we will try to determine. Okay, for that, what we will do, after drawing the x-axis and the y-axis mutually perpendicular, means that this is a 90 degree. After doing this, what is our next work? Our next work is to make a scale of the plot. We have to choose a suitable scale. And as per the data which is provided, we need to choose a convenient scale where we can make the plot quite clear and visible. Okay. So here we can see 5 small division is equal to 1 second. Can you see 1, 2, 3, 4 and 5? These are the 5 small division. So this is equal to 1 second. Again, next 5 small division is again 1 second. So it is 1 second, 2 second, 3 second, 4 second. Where is it given? It is given along the x-axis, which is the time axis. So along the time axis, it is the x-axis, 5 small division is equal to 1 second. Next, you can see the y-axis, which has the position in meter. Always write what you are showing in which axis. Like in the x-axis, you have written time. What is the unit of time? That you write within bracket, second. So don't write SEC, write small s. For position, write meter, because that is what is given in the table. Okay, if you see, you will see, okay, it is given in meter and here it is given in second. At times in position within bracket, you can write M, and beside time, you will write S. Okay, so you can do this also. Now what you will do, you will plot it in this manner. Okay, y-axis has 5 small division is equal to 20 meter. So again, you need to identify the 5 small division. You see 1, 2, 3, 4 and 5. So this is again 20 meter. The next 20 gives 40. Next 20 gives 60. So on. Now you will see the data. Okay. The data says when it is 0 second, the distance covered is also 0. So when it is 0 second, the distance covered is 0, for which the plot starts from origin. This is the point which gives 0, 0. We know it shows x, y, any point. Okay. So that will give 0, 0. That is the origin. And for x-axis is time. So 1, 20 will be a point like this. Okay. Now in the x-axis, let us see. In the x-axis, 1 second is this, and 20 meter is here. So this is the point. Okay, 1 second and 20 meter. So from 20 meter, if you draw this, it comes to 1 second, and this is the point which shows 1, 20. That is 1 second, 20 meter. Next, in 2 seconds, you have 40 meter. So you take a scale and draw 2 seconds. This is the line which is parallel to y-axis, and the line which is parallel to x-axis from 40 will meet at a point. And what are the coordinates of this point? X-axis is 2, y-axis is 40. So 2, 40. 2 second, 40 meter. Similarly, you have a point like this, 3 second, 60 meter for this plot. Okay. So likewise, you will get all the points. After 60, it is 4. This is 4, 80. And this is 5, 100. And this is 6, 120. So you will plot it in this manner. Okay. So like that, when you will get the points, you will just join the point. And when you join the point, you get a plot which is like this. So this is one point which is 1, 20. This is another point which is 2, 40. Third, 3, 60. Fourth, 4, 80. Fifth, 5, 100. And 6, 120. And when you join all these points with a scale, you will get a straight line like this. You are getting a straight line which is drawn in the book like this. Okay. So what do you notice? Once all the points are drawn, they are plotted. Connect them to create the position time graph for the vehicle's motion. And what do you notice? What is the nature of the plot? It is a straight line for the data which is given. And of course, passing through the origin. A straight line which is passing through the origin. Now, what does it mean? Suppose I have to see any intermediate position. In between 1 and 2, I can get a point 1.5. For that, I will get a point over here. Say this should be 30. Okay. For 2.5, this is a point which is 2.5. And for this, I should get something which is 50 meter. It should be like this. So the intermediate points also shows the possibility of the plot. That means what? At 1.5 second, it should cover from the trend, from the nature of the plot, it should cover 30 meter. At 2.5 second, it should cover 50 meter. And why is it so? Because the vehicle is moving with a constant speed. So if the nature of the plot is passing through the origin, and what is origin? Origin is 0, 0. This point is the origin. Passing through the origin, and what? It is a straight line. Okay. So it is a straight line passing through the origin. Such a plot actually shows that the vehicle is moving with a constant speed. But of course, if it is a distance time or position time plot. So position being on the y-axis and time on the x-axis. Next, another example is given. This is the example and this is the table. We can see for time there is 2 seconds gap. See, 0 to 2, 2 to 4, 4 to 6, 6 to 8. Everywhere there is a 2 second gap. And for position again, 0 to 1. Now we can see 1 to 4. Again 4 to 9. So here it is not a particular pattern. Okay. Now if I say 0 to 1, 1 meter. 1 to 4, 3 meter. 4 to 9, 5 meter. This is the gap. Okay. So we need to choose a suitable scale. Again, choosing the scale. If we follow x-axis, 5 small division is equal to 2 seconds. So again, this is the x-axis where we are showing what? We are showing the time. This needs to be written. Okay. And this, the unit is second, x-axis. So 5 small divisions. See, 1, 2, 3, 4 and 5. 5 small division is equal to 2 seconds. See, from 2 to 4, again a difference of 2 seconds. 4 to 6, difference of 2 seconds. So x-axis will show 5 small division is equal to 2 seconds. y-axis will show 5 small division is equal to 5 meter. Okay, so from 5 to 10 to 15, everywhere 5 meter gap. Now you search for the plot. Like, see from 0, 0. This is the point, 0, 0. This is the point. From here we can see 2 seconds, 1 meter. Okay, so if 5 small division in the y-axis is equal to 5 meter, then obviously 1 small division needs to be 1 meter. And here is your 1 small division against this point. So 2 seconds and 1 small division. So 2 comma 1. 2 is the x-axis and 1 is the y-axis plot, 1 meter. And another one in the second, you can see what it is. This is 2 comma 1. Then you can see 4 second, 4 meter. Okay. So 4 second, this is what you can see, 4 second. Here it is 4 second and this is the 4 meter. So this is 4 comma 4. Like this, all the points are obtained. All the points are obtained. Now, if you join the points, you get a plot which is shown in figure 4.12. And see, it is quite different from the previous plot. It is not a straight line passing through the origin. Yes, it is passing through the origin, but it is not a straight line. It's a curved line, right? So how do you interpret the graph? Interpretation of the graph we can see here, where we can see if it is a straight line passing through the origin, then it is showing a constant velocity for a position time plot or distance time plot. And if we see it is a curved line and the gapping is not uniform. See, the gapping is not uniform, right? Magnitude of the object, magnitude of the displacement is increasing. That is what we have seen. Displacement from 0 to 1, 1 meter, 1 to 4, 3 meter, 4 to 9, 5 meter, just goes on increasing. And so this is showing something which is not a constant velocity. It is a changing velocity. No more a constant velocity. It is a changing velocity. So how do you interpret the plot? In first one, you can see for the distance time plot or the position time plot that the velocity is constant. Okay. And this is showing changing velocity or different velocity. That is the B1. Okay. Now, for this, you have to understand that if the plot is given, you may be told to analyze the plot. And how will you analyze the plot? You have to see the nature of the plot and judge accordingly. Now, which physical quantity can be obtained from a position time graph? Now, position time graph depicts many things. Okay. How? Suppose we see, let us see this activity. In the position time graph, we plot it. Consider part AB. This is the part AB. Okay. Here is the part AB. Consider a part AB of the graph shown in this figure. From A, draw a line parallel to x-axis. So you are drawing a line from A. What is this point A? That you need to know. So A was actually depicted by 2, 40. And what was this 2? Second and 40 meter. So that was the point A. So from point A, what is being done? A line is being drawn which is parallel to the x-axis. So that is AC, parallel to the x-axis, right? Another line parallel to the y-axis is being drawn. Another line parallel to the y-axis is drawn. Okay. So for this, we can see this is the line which is parallel to the y-axis. and here is the line which is parallel to the x-axis. So, extend the horizontal line from A and a triangle ABC is formed. That means if this horizontal line AC, okay, is extended, then we get a triangle like this, that is from B again towards C if we draw a line. So what we got is a triangle ABC. Now what do the side BC and CA of the triangle represent? If you see BC, it is actually parallel to the y-axis, isn't it? And CA is parallel to the x-axis, right? Now if I say B means it is having position equal to S2. At B, the position is S2, time is T2. So I can say it is T2, comma S2 at B, right? T2, comma S2, that is what? It is the time and the distance, and at C, it is T2, comma S1. You see the point C, time is T2, time is T2, and what is happening? Distance is S1. So this is the plot C. And what about A? A is T1, comma S1. T1, comma S1. Now it is said BC is how much? BC is how much? BC is having, if this is S1 and this is S2, BC should be this much. For this much, it is S2, this much is S2, S2 minus S1, that is BC, S2 minus S1. And what is CA? Similarly, CA is this much. So from here to here, it is T2. So T2 minus T1 will be CA. So here, as per the plot and as per the equation of the average velocity, what do you get? Velocity is distance by time. So this is equal to S2 minus S1 by T2 minus T1, and from the plot we are seeing S2 minus S1 is what? It is BC. So BC is equal to S2 minus S1. And what is CA? CA is equal to T2 minus T1. So in place of S2 minus S1, you can write BC, and in place of T2 minus T1, you can write CA, right? So here you see S2 is how much? 80 meter. S1 is how much? 40 meter. So 80 meter minus 40 meter divided by T2 is what? 4 seconds minus 2 seconds. And this is it, the value 20 meter per second. Why? Because it is 80 minus 40 is 40 meter. 4 seconds minus 2 seconds, 2 seconds. And you make it to the simplest form, it is 20, and the unit should be meter per second. So what is this? This is the value of the average velocity that you have obtained graphically, right? So geometrically we can see BC by CA. Now you can say that this we can obtain from the formula as well. Yes, we can obtain from the formula. We are relating it to the plot. So what you have written from the formula, that is V is equal to S2 minus S1, distance, change in distance by change in time. T2 minus T1, that we have written, right? That is delta S by delta T. It is. So here we can see this is equal to BC by CA. Now geometrically, BC by CA, BC is corresponding to the y-axis, line parallel to the y-axis, and CA line parallel to the x-axis. This is geometrically slope of the line AB. That is slope of the line AB. So this is slope BC divided by CA. So we can say that from the distance time plot or from the position time plot, if we get a straight line, a linear plot, then the average velocity should be equal to the slope of the line. Okay, whichever line, whichever part of observation it is. Now here our part of observation is AB. So this part of the plot AB, if we draw a slope to it, or if we find the slope of the line, then if we draw the perpendicular, that means we can draw a line parallel to the x-axis, extended, parallel to the y-axis, extended, and we find the slope. That will correspond to the average velocity. So, in order to understand this, first you have to understand how to frame, how to form a plot. That is what we started with. How to actually connect the points and draw the plot. If we get a linear plot, what does it mean? It means constant speed. If we get a plot which is a curve, what does it mean? It means the velocity is changing. Now, if we try to plot it and we try to interpret the graph and what all outcomes are there from the position time plot, we can find the value of the average velocity. Yes, mathematically also and graphically as well. Mathematically using the formula S2 minus S1 by T2 minus T1, and graphically by finding the slope of the line which is a part of the plot, right? So ready to go beyond? For the case of a curve also, velocity at any instant can be calculated geometrically. Yes. Now for this, if it is a curve, we will do it of course in higher grade. We have to find a point, we have to draw a tangent to the point, and we have to find the slope of the tangent. Now what is a tangent? How to find the slope of the tangent? We have to keep it for higher classes, right? Next, example 4.6. What does the graph shown in figure 4.15 indicate about the nature of the vehicle? You study the time. You see at 1 second, the position, the distance is 40 meter, at 2 seconds also 40 meter, at 3 seconds also 40 meters. So for every time you are seeing the distance is same. That means, it means the position of the vehicle is not changing with respect to time. Or we can say the vehicle is at rest. So a straight line parallel to the time axis on a position time graph, it shows that the body is stationary, is at rest. The body is at rest because it is a position time plot, and with respect to time, the distance is not changing. Go to example 4.7. The position time graph of two objects A and B are given. Okay. In this, magnitude of average velocity of which object will be higher? Now, how to see this? By making lines parallel to the axis. The way we have seen, we can draw the lines parallel to the axis. We can find the slope and then we can predict. Okay, it has been found that the displacement of object B is more than object A for the same time interval. What it has been found? It has been found that the displacement of object B is more than object A for the same time interval. So this is the time interval that was chosen. Okay, this time interval is chosen. So from here you are seeing that a slope of the line is drawn. Perpendiculars are drawn and slope of the line are found. So moreover, you can also see in the other way round that this is a plot which is more steep for the B. So obviously the slope will be greater over here. Okay. So here for this position, you can see at B, this is the position, and here is one position being chosen. Okay, this is the point. At this point, this is the position. So I can say S1, I can say S2. Here again, I can say this is T1. Here again, I can say this is T2. So similar to the previous case, we can find the slope, and it was seen that the slope of the line for B plot was greater. Thus, the velocity of B is higher than that of A. Why? Because slope of line of B is steeper. So from the nature of the plot, if you just see the plot, then also you will come to know which is having a steeper slope. Okay. Next, velocity time graph. Previously it was what? Previously it was position time graph. Now you are seeing velocity in the y-axis in meter per second and time second. Unit is second. Velocity time graph of an object. It shows what? It shows the change in velocity with respect to time. And these two plots you can see, one shows an increasing velocity and the other shows a decreasing velocity. Okay, table 4.5. With time the velocity goes on increasing, and table 4.6, with time the velocity is going on decreasing. Now, what does the shape of the velocity time graph indicate about the nature of motion? If you see, the plot is actually parallel to the x-axis. That is, it is parallel to the time axis. That means with time, the velocity is not changing. With time, the velocity is not changing. That means velocity is constant. So for that case, if velocity doesn't change with respect to time, we can say there is no acceleration. So acceleration is 0. In the next case, you see that in equal intervals of time, velocity is increasing by equal amount. The gap is same. Okay? In equal intervals of time, velocity is increasing by equal amount. That means it can be, say in this one, 4.5 we can see. Okay, in 4.5, table 4.5, see here there is a gap of 5 seconds, next 5 seconds, next 5 seconds. So for every 5 seconds, there is a distance of 2.5 meter. There is a velocity of 2.5 meter per second. See 0 to 2.5, 2.5 to 5, 5 to 7.5. So everywhere the gap is how much? It is 2.5 meter per second. That means there is equal intervals of time and the velocity, the increase in the velocity is also equal. So this is a motion which is having constant acceleration. Now you may say why acceleration? Because the velocity is changing with respect to time. Wherever there is a change in the velocity with respect to time, we will say there is acceleration. That means the motion is accelerated motion and the acceleration is constant here and in the direction of velocity. It is constant and is in the direction of velocity because it is increasing. Increasing velocity with constant acceleration is a uniform plot and increasing plot. Now if I see that the velocity is decreasing with the same difference. Okay, the difference is same. The decrease is same for same time interval. See, 0 to 5 second, 5 to 10 second, 10 to 15 second, 15 to 20 second, 5 second gap. Again, there is a decrease of how much? 3.5. Okay, so here it is 2.5. Again, we can see 2.5. So this is again 2.5, 2.5 here. That is the change what is happening. But it is decreasing, not increasing. So if it is decreasing, what does it mean? That is, velocity is decreasing by equal amount for equal interval of time. Change in velocity is there. So we will say acceleration. But the acceleration is constant in the opposite direction of the velocity. For such a case, what do we say? If the acceleration decreases, we use a term which is known as deceleration. But then also let us see that this is decreasing velocity with constant acceleration. What is the nature of this plot? Increasing velocity with constant acceleration, and here it is decreasing velocity with constant acceleration. One is increase in velocity, the other is decrease in velocity. So when the velocity of the car remains constant, then in velocity time graph, if velocity of the car is constant, the velocity time graph will have a straight line parallel to the x-axis. This is one case. Okay. And acceleration is 0 for such case. Now, in the B, that is a straight line velocity time graph. This is the case 2, second type of plot. What does it mean? It means velocity is increasing with constant acceleration, of course, in the direction of the velocity. And for C, the third case, indicates velocity is decreasing with constant acceleration, but in the opposite direction of velocity. Yes, opposite direction of velocity. Velocity is increasing in one direction and acceleration is decreasing in the other direction. Now, which physical quantity can be obtained from the velocity time graph? Like in the previous case, from the position time graph, which physical quantity you got? You got average velocity, right? But here, from the, I will say, velocity time graph, which physical quantity are you getting apart from finding the velocity of the object at each instant? You can find the acceleration. Okay, acceleration is the change in the velocity with respect to time. That is what you can do. You can find the slope of the straight line in the velocity time graph in order to obtain the acceleration. So what do we see? The slope of the line on velocity time graph gives how fast the velocity is changing with respect to time. That is acceleration. Change in velocity with respect to time is acceleration. Okay. Now, if there is no change in the height of the line, that means acceleration is 0, which we had seen in case A, 4.17a. In B and in D, what was happening? Now, here we can see that consider a part of the line AB. Again, the same way, you have to find the slope of the line, or you have to say the change in the velocity divided by the change in the time. So, V minus U by T2 minus T1. So, which is equal to BC by CA, that is Y by X, which is the slope. Okay, so B was having 10 meter per second value. B was having. So this is B, right? So here V is this much final velocity minus initial velocity is this. So this is V, this is U. Okay, final velocity minus initial velocity divided by T2 final time minus initial time. So if you do this, you will get acceleration, which is the average acceleration between the time interval. When there is a time interval, then it is average acceleration. Otherwise, if it is at a particular time, it is instantaneous acceleration, which you don't need to do right now. Okay, so this was the value of the average acceleration. Be careful regarding the unit. It is meter per second square. Either you write it in this manner or you write in this manner, meter second to the power minus 2. Okay, so in the C case, what was it? You have seen the plot C. This was the plot C, right? This was the plot C, decreasing velocity with constant acceleration, right? So we obtain average acceleration to be minus negative of it. So negative of the increase, that is minus 0.5 meter per second square. And what does this minus sign indicate? This minus sign indicates that the direction of acceleration is opposite to the direction of the velocity. That means as the velocity is decreasing, you know, with time the velocity is decreasing. So the direction of acceleration is opposite to the direction of velocity. Why is it so? Because with time the velocity was decreasing. Now, what does the area under the plot show? Which plot? The velocity time plot. What does it show? So, let us see what it is showing. So, here we see that except that some parts between the line on the graph and the time axis are shaded. This part is shaded. Now, what does it signify? So, for this, we have to see. This is a rectangle. It is forming a rectangle. And the rectangle is OABC. Area under the plot is the area of the rectangle. That is multiplication of the two adjacent sides. OA is one such side. This is OA and OC. OA is the velocity and OC is the time. So we know very well, velocity into time is actually displacement. So velocity, in this case we can see velocity is remaining constant and it is equal to the average velocity, right? Now area under the plot should be now displacement, because velocity into time means what? It means displacement. And if velocity into time is the area of the rectangle, that means that is the area under the plot. That should actually show what? It should show displacement. So area of the triangle shows displacement of what type of plot? Velocity time plot. Okay. So here again you see displacement between 10 second to 20 second. Where is that? This is 10 second. This is 20 second. So this is the displacement. So if this is it, you will draw a line from 10 second to the plot meeting at A. Draw a line from 20 second to the plot meeting at B. Now you get the area under the plot as what? It is ABDE. See, area of ABDE. That is it. Now you have to divide it in this manner. From A you draw a perpendicular to BD. This is the perpendicular. Name it as C. And so you get a triangle ABC and a rectangle ACDE. Okay. So let us see it clearly. This is it. This is a triangle ABC. So this is your triangle ABC and this is the rectangle ACDE. If I separately find the area of the triangle and the rectangle and add them, then I will get the area ABDE, the total area. So area of the rectangle is product of the two sides here, adjacent sides, and area of triangle is half into base into height. So half base, if I say CA, so I mean base is BC and height is CA because this is the perpendicular. Okay. So what you will see? You will see half into base into height. So you can consider this also base. This is height. That also you can do it. Okay. So AC as the base, height is BC, perpendicular it is. So when we do it and we place the value very minutely, see what we have done. Area of the rectangle was ACDE. Again, I am erasing this part. So we see ACDE and it is CD. How much is CD? This is CD. And the value is this. CD is parallel to the velocity axis and the value is 5. So Here CD is equal to 5 meter per second. What is DE? DE is a point. D is a point on the x-axis. E is also a point in the x-axis. D is at 20, E is at 10. So 20 minus 10 is equal to 10. So here again, DE is equal to 10 second. What is CA? CA is parallel to DE and its value will be same as DE. So I can say CA is equal to DE is equal to 10 second. Can't we say C is at 20, A is at 10. So obviously difference is what? 20 minus 10, that is 10 second. What is BC? BC, we can see this much. B is at 10 meter per second, C is at 5 meter per second. Subtract them and you will get 5 meter per second for BC. Just place the values over here. You place the values and what you will get is 75 meter is the displacement. So what did we see? The area, that is by finding the slope and area from velocity time graph for motion with constant acceleration, we can determine acceleration and displacement respectively. That is, if we find the slope in the velocity time graph which has a constant acceleration, we can determine the value of acceleration. And if we find the area under the plot, what we can do is area under the plot will give the value of displacement. So that is how we can interpret it. So here is a summary of what you have seen. A graph helps us understand motion, yes, easily by showing how one quantity changes with the other. So we have one type of graph which is the distance time graph. This is the distance time graph. In distance time graph, in the y-axis, you have distance to be plotted and in the x-axis, you have time to be plotted. An interpretation is a straight line, upward line. If it is, then it shows uniform speed. If it is a curved line, then it shows non-uniform speed. If it is a horizontal line, distance does not change with respect to time. So the object is at rest. These are the three things that you have seen. Okay. So slope of the line, which slope? The slope of the distance time plot shows the speed. Okay. So slope of the line shows the speed. That is the interpretation from distance time plot. It shows the speed. What about velocity time graph now? We have seen two types. One is the distance time or position time and the other one is the velocity time. Again here, x-axis will show time and y-axis will show velocity. A horizontal line which is parallel to the x-axis means uniform velocity. Upward sloping line means velocity is going on increasing and it is acceleration, right? Downward sloping line means velocity is decreasing and it is deceleration or retardation. Retardation means negative acceleration. That means acceleration is negative to the direction of the velocity. That is what we say. And a line on the time axis means velocity is 0. Yes, the object is at rest. So these are the four interpretations from a velocity time graph. And you need to understand each and every interpretation. If you have any doubt, feel free to ask in the comment section. Now, in a distance time graph, we can find the area as the speed, the velocity time. From there, we can get the acceleration. So, slope of the distance time graph shows speed. Slope of velocity time graph shows acceleration. area under the velocity time graph shows the distance covered. So these 3 points are extremely important in order to remember how to find the speed of a moving object from a distance time graph, how to find the acceleration from a velocity time graph, and how to find the distance covered by a moving object from a velocity time graph.